Okay, 7.5, work. Work is a physics concept, and the formula for work is a force times distance. So the force applied on an object multiplied by the distance. Now, usually work is the force is constant over a certain distance. So say we move 7 meters and we are pushing with a force of 4 newtons the entire way, right? 7 meters, 4 newtons, we multiply those, that equals 28. And work is measured in joules. So this is simple because it's force times distance. But sometimes force isn't always the same. For example, when you have a spring, the force is equal to K times X, which is K is a constant time, but it increases with each distance. Now, the integral is the area under the curve, and the area under the curve is really just the y multiplied by the x at each infinitely small point. So if we use this equation and we find the integral of it, we can use that, or if we integrate the formula for this, we can find work. For example, say a spring is compressed about, let's say the spring is compressed about 5 inches, or 5 inches, right? So spring is compressed 5 inches, and it takes 500 pounds. Now, if F is equal to K times X, we have F, we have X, we need to find K. F over X equals K. So K is equal to F over X. So F is 500 pounds divided by 5, 100 pounds per inch. Now, this gives, so now that we have our K, how much will force, let's say we need to know how much more force it will take to move the spring down 5 more inches. Now, in physics, there is a formula called 1/2 kx squared is equal to energy, right, in the spring, and energy is equal to work. Well, if we integrate, well, we'll get back to that. We want to integrate integral of f of x, which is the force, so we want to integrate f of x, right, which will be the integral of k times x, which will be the integral of 250x in this case. From the bounds, we start at 5 inches, we want to compress 5 more. 5 to 10. Because 5, yeah. Now, when we integrate this, that x is going to come up, is going to, so 250, it's going to become 1/2 times 250 times x squared, evaluated at 5 to 10. Well, that's going to be 125 times x squared, evaluated at 5 and 10. Now, when we do this, 10 squared is 100, so 125, 10, 5, 100, minus 5 squared, which is 25. That is 75. And that should equal 935. Now, this formula right here, this is a formula we're given in physics that gives us the energy. Now we want to find the work, which is the change in energy, so we can subtract the 2kx squareds. So we can do, generally, you can do 1/2 kx squared minus 1/2 kx squared. So this is the energy we had initially. This is the energy we will have final. The subtract the two is the energy we needed to compress it even more, and that is going to be equal to the work. So 1/2 250 times 5 squared. No, 10 squared. Yes. Yeah. Times 10 squared. Minus 1/2 250 times 5 squared. 125 times 100 minus 125 times 25. Now, if we notice, we can factor out this 125 and get 100 minus 25, which is the same thing we had here. It's these two are the same, so this will also equal to, that was 9375, I forgot one. That will also equal to 9375. Now, this can further be seen if we just integrate the formula of kx, where k is a constant. Well, x increases by, we divide by 2. That is 1/2 kx, we 2 up there, 1/2 kx squared. Integrating this formula gives us this formula. And that's how it all fits together.